Hello, I'm Amaia, and the working title of my bachelor's thesis is The Use of the Auricular Transcutaneous Vagus Non-Invasive Electrostimulation in order to study the brain's functional connectivity in a mouse model of Fragile X syndrome, and it's supervised by Saitua. Now let's talk about the main topics of this thesis. So first of all, what disease are we going to focus on? We're going to study Fragile X syndrome, which is the most common monogenic cause of inherited intellectual disability. Moreover, it can be very easily characterized in mice by knocking out their FMR1 gene. Notably, this model improves their memory performance when administered ATVNS, which is the aforementioned electrostimulation. So now that we have the mice model, which aspect of this model are we going to focus on? So we're going to focus on cognition. Why? Well, we're going to use electrostimulation of the vagus nerve, which Albert already has explained a little bit about. But what happens is that some afferent fibers of these nerves end in the nucleus of the solitary tract, which is a relevant relay area for visceral information. From there, this afferent information is distributed to many brain regions, including the locus coeruleus. This provides innervations for different regions of the brain, such as hippocampus, amygdala, prefrontal cortex. Therefore, it has been thought that this locus coeruleus could regulate cognition, which is in we are interested in. Okay, but what are we going to study about cognition? Well, we're going to try to measure the brain's functional connectivity network before and after the electrostimulation. In order to do that, we'll measure the expression of immediate early genes, which are considered a reliable proxy for neuronal activity. Specifically, we'll perform the quantification of C-force density in different brain areas. Using this and correlation-based analysis, we'll obtain brain network and functional connectivity measures. In the figure you can see here, we have an example of functional connectivity matrix. In the rows and columns, we can see brain areas, different brain areas, and the matrix entries are positive and negative correlation values. So, all in all, the main goal is to generate a map of functional connection that will be different in Fragile X syndrome mice than in wild-type littermates. We expect that said electrostimulation will affect the functional connectivity network for both genotypes, probably making the Fragile X syndrome mice look similar to wild-type littermates. This new information will be useful in order to better understand the brain's connectivity after non-invasive electrostimulation in the context of intellectual disability disorder. Thank you very much for listening.